Hey everyone, in this video let's take a look at question 647, palindromic substrings on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question we're given a string S and you want to return the number of palindromic substrings in it. A string is palindromic when it reads the same forward and back, and a substring is basically contiguous. So what this means here is that in these examples, let's take a look at them. For the string ABC, we have a couple of palindromes, right? Like for A in itself is a palindrome, B in itself is a palindrome, and then C in itself is also a palindrome. So we have the value 3 here. For something like this, AAA, you can kind of think of all of these as palindromes, A and then A and then A corresponding to these three individual A's, and then AA, AA, AAA, etc. I think these are bad examples, but maybe something like, for example, if we had race car, right? Or maybe not race car, let's do something like, maybe this is like PP, and this is something like APPA, and then this is like Q, right? So what are the substrings here? Well, it would be PP would be like one of them, APPA would be another one, and then maybe if this was like a Q, then QAPPAQ would be like another one of them, so we would return 3. But anyways, I'm not going to spend too much on this problem. We've done an extremely similar problem in that we just have to change like 2 lines in that one, and that question is longest palindromic substring. In this one, essentially what we do is we're given the string and you want to return the length of the longest, not the length, but the longest palindromic substring. And we worked our way through this one. And actually what we ended up doing is we created a DP array such that DP at I and j is equal to true if it is a palindrome. So what does that mean? Well, let's take a look at something like this. And again, this video, go ahead and watch this if you want like a rundown of what we did here, but I'll try to quickly explain what we did. So we started from a recursive approach and then we moved backwards into a dynamic programming one. So basically like these values over here, all of these blue values over here, they will be true because what it indicates is that this value over here, for example, this C and then this C, it's a palindrome. This A and then this A is a palindrome. Notice how we're only considering values on this diagonal and upwards. We don't consider any of these ones because this would be like the string CR, which doesn't exist. This over here we can see is the string R, then this one is like the string RA, this is like the string RAC, and in real dynamic programming, like these are stored as, like this is, you refer to it as like the integer index. So here I just put the string to kind of make it easier to see, but that's essentially what it's saying. And so basically like as part of this, what we did is like we were on a specific, we traversed this array and we were on a specific value. Maybe like this one was this value over here. And what we did is we checked to see like, was this value the same? So for example, what does this refer to? Well, this refers to EC, right? It refers to EC. So if this value was the same, like maybe this was something like EE, right? This was something like EE. Now, maybe we shouldn't take this value. Let's suppose this value here was an E, right? Let's suppose this value over here was an E. So then what does this mean? It means that this location over here is the string ECE. And so if the E and the E here match, then we want to look for this middle element here, which is actually the string located right over, actually, I guess, did I do this correctly? E and then E, and then if we want to look for the C, it is this string here, right? It is I plus 1 and then j minus 1. So if this is I and j, I plus 1 is here, j minus 1 is here. And so this is the string C. And so we can see that this is a palindrome, and if these two are the same, then this entire thing is a palindrome. And so we would mark this value here as true. And so this value here would be true. And so essentially like we would go through our array and we would create like true everywhere that there is a palindrome. And so what it essentially means is, for example, if this is true, it means that the value ACEC is a palindrome. Obviously here it's not, but we just say it is. And so we basically just went ahead and did that. So all we really need to change in this code is, I'll go ahead and actually copy it. So over here, I'll go ahead and copy it. And again, watch that video, but hopefully I explained that one. So we have our 2D DP array here, and then DP at I and I is true because like the individual just are individual A, these are all palindromes. So really I want to keep a count here, which I'll just call res, and I'll remove my res over here. And so every time this happens, we increase our res by 1 because that's a palindromic substring in itself. And then basically here, what we did is we essentially checked to see whether the string we're currently forming, which is a palindrome, is longer than the longest one. But here we don't care about length, right? Here we just care about the total number. So here again, we just increase res by 1. And so in the very end, we just return res. And so that is his solution. So it is exactly the same as the palindromic substring, but we're just counting. And so this is a O of n times n, like n squared, where n is like the length of the string. And for space, it is the same thing. So again, watch this video for definitely like to understand like how we came about the solution. But hopefully here you understood like how to do it. Thanks for watching.